let's look at solving quadratic equations by factoring. So our first example is x squared equals negative 5x. And if we look at our first step, it will be to move all terms to one side of the equal sign with 0 on the other side. In other words, put the quadratic equation in standard form. So if I add 5x to both sides, I end up with x squared plus 5x equals 0. Next, factor the non-zero side. And with factoring, we always look to see if there's a greatest common factor first. And in this case, our GCF is x. And when I factor x out of everything, I get x plus 5. So our factored expression is x times x plus 5, and then still equals 0. And then we will use the zero product property. So I will set each factor equal to 0. So x equals 0, or x plus 5 equals 0. And now we'll solve those, get the variables by themselves. And so my first one, we already have x by itself, so x equals 0. And the second one, we will subtract 5 from both sides, and we get x equals negative 5. And we can always check our solutions by substituting our values into the original equation. When I do that with 0, we get does 0 squared equal negative 5 times 0. And here 0 equals 0, so yes, that first solution works. And we'll check the negative 5. Does negative 5 quantity squared equal negative 5 times negative 5? 25 does equal 25, so this second solution also works. So therefore our solution is x equals 0 or negative 5. We could also write it together, just separated by a comma, as x equals 0, comma, negative 5. So that was one type of factoring. Let's look at a second example with a second type of factoring. So here we have x squared equals 5x minus 6. I want to get everything in standard form, so I'll subtract 5x and add 6 to both sides. X squared minus 5x plus 6 equals 0. There is no GCF, so we'll set up our parentheses. It equals 0. Our variable that we're using is x, and our x squared term, our quadratic term, had a coefficient of just 1. So now we need to find factors that multiply to 6 and add to negative 5. So positive 1 times positive 6, negative 1 times negative 6. Positive 2 times positive 3, negative 2 times negative 3. And this last pair adds to negative 5. It's the only pair that will add to negative 5. And so now that we have found this pair, we will fill in our parentheses. So x minus 2 times x minus 3 equals 0. And now we'll use the zero product property. So x minus 2 equals 0, or x minus 3 equals 0. Solve both of these, so we'll add 2 to both sides for the first equation and get x equals 2. In the second equation, we'll add 3 to both sides and end up with x equals 3. So our solutions for this second example are x equals 2 or 3. Let's look at a third example. Here we have 4x squared plus 15x plus 9 equals 0. This is already in standard form. There is no GCF. We're going to try factoring. So to factor something like this, where we have a coefficient in front of x squared that's not 1, I'm going to draw an x, and at the top of my x, I'm going to fill it in by writing a times c. In our case, that's 4 times 9, or 36. And at the bottom of my x, I will put my b term, which is 15. And we're going to look for numbers that multiply to 36 and add to 15. And those would be 12 and 3. 12 times 3 is 36, and 12 plus 3 is 15. So now we're going to rewrite our expression on the left-hand side, keeping our first term the same, the last term the same, and expanding out the middle using the 12 and the 13 that we just found. So 4x squared plus 12x plus 3x. So those are the 12 and the 3 that we just found, plus 9. So the last term stays the same, and this still equals 0. So we expanded out the middle. We have not changed the value of our expression. And now we're going to factor this by grouping. So we're going to split this in half, and then we'll look for the GCF for the first two terms, the 4x squared and the 12x. And my greatest common factor is 4x. When I divide 4x out of those first two terms, I'm left with x plus 3. And now we'll move to the second half. 3x plus 9, we want to find our greatest common factor for those two terms. Here it's 3, and because the third term is positive, our GCF stays positive. When I divide 3x plus 9 by 3, I'm left with x plus 3. And again, it still equals 0. And now we see we have a common binomial term, and we will factor this out, so x plus 3. And then in our second set of parentheses, we will put our two greatest common factors that we had factored out, the 4x plus 3. So factored, we have x plus 3 times 4x plus 3, and that still equals 0. Using the zero product property, I'll set each factor equal to 0, so x plus 3 equals 0, or 4x plus 3 equals 0. Solve both of these for x, so I'm going to subtract 3 in the first equation and get x equals negative 3. In the second equation, I'll start by subtracting 3 from both sides. And now I get 4x equals negative 3. And now I'll divide both sides by 4, and I'll end up with x equals negative 3/4. So for my third example, our solution is x equals 3 or negative 3/4.